warahmatullahi wabarakatuh. Hello everyone, I'm Ilma Nabila from IPSE 2019. So today I want to explain you about Newton's law. Happy watching! Newton's laws of motion. The phenomenon of movement objects studied in physics cannot be separated from Sir Isaac Newton's discovery. In 1687, through his book entitled Principia, Newton introduced three laws of motion, which became known as Newton's laws of motion. Now, it's more than 300 years after Newton introduced its laws for the first time. Newton's laws of motion are used in everyday life, such as when placing book on a table, riding a bicycle, or swimming in the pool. So, let's jump into the first law. Newton's first law. An object at rest will remain stationary, and an object in motion will continue to move at a constant speed unless there is an external force affecting it. Newton's first law is often called the law of inertia because it contains the object's tendency to maintain its state, or what it called an inert state. The greater the mass of the object, the greater the inertia or the tendency for the object to maintain its state, and vice versa. This is an example of Newton's first law. It's the coin experiment. The coin has inertia, meaning it really wants to stay in one place. If you move the coin slowly, it isn't fast enough to overcome the force. But if you flick it quickly, the coin stays in one place and then drops into the cup. Remember that an object at rest will remain at rest. Newton's second law. The resultant force on an object is equal to the object mass in kilograms multiplied by its acceleration. You have to remember that the resultant force is the sum of all forces acting on the object. To calculate the acceleration of an object, we must first add up all the forces acting on the object. When the resultant force on an object is more than zero, or there is a force whose magnitude exceeds the sum of the other forces, acceleration will occur. A real-life example of Newton's second law is a full shopping cart versus an empty shopping cart. In Newton's law, it says that if two objects are pushed with the same force, the object with the greater mass will have slower acceleration than the object with the less mass. The law describes that the less mass an object has, the greater the acceleration. This can be related to the shopping carts. If a person pushes two carts, one empty and one full of things or these boxes, with the same force, the empty cart will travel further and accelerate more compared to the full cart. Newton's third law. In every action force, there is always an equal and opposite reaction force. Suppose you push on a wall. According to Newton's third law of motion, forces always act in equal but opposite pairs. Another way of saying this is for every action, there is an equal but opposite reaction. This means when you push on a wall, the wall pushes back on you with a force equal in strength to the force you exert. When one object exerts a force on another object, the second object exerts the same size force on the first object, as figured in this slide. Alright, that's all about Newton's laws of motion. Thank you for your attention. I'm Ilma Nabila. See you. Wassalamualaikum warahmatullahi wabarakatuh.